Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 8 of International A-Level Edexcel P4 January 2022 paper. So it says that with respect to a fixed origin O, the points A and B have position vectors 662 and 607 respectively. The line L1 passes through the points A and B. The requirement of part A is to write down an equation for L2. Give your answer in the form R is equals to P plus lambda Q, where lambda is a scalar parameter. So here we have line L1. Okay, let's say this point is A and this point is B. So here I can take the point A as the starting point. Okay, and we are going in the direction of AB. So R is equals to P plus lambda Q, where P is basically the position vector of the starting point. So in place of P, I'm going to write OA plus lambda times Q, and Q is basically the direction vector of the line. So we are going in the direction of AB. So in place of Q, I'm going to write AB vector. Okay, so first of all, we are going to find the AB vector according to vector subtraction law, which is OB minus OA. So OB vector is 607 and OA vector is 662. All right. So therefore, AB vector is the I component is 0, J component is -6, and K component is 5. Okay. So R is equals to OA plus lambda times AB. So therefore, R is equals to 662 plus lambda times 0 minus 6, 5. So this is supposed to be our answer to part A. So alternatively, what you can do is you can take point B as the starting point and you can go in the direction of BA, or you can also go in the direction of AB. And alternatively, if we consider the starting point A as we have considered in this case, we can also go in the direction of BA as well. So there are multiple ways to express your vector equation of a straight line. Okay, so far we have achieved the final answer. This is the answer of part A. Now let's move on to part B. So here we have some information before part B that the line L2 has equation R is equals to 314 plus mu times 159, where mu is a scalar parameter. The requirement of part B is to show that L1 and L2 do not meet. So here I'm going to erase the working of part A so I can solve part B on the same page. So we need to show that L1 and L2 do not meet. So the equation for L1, which we obtained in part A, was R is equals to 662 plus lambda times 0 minus 6, 5. Okay, this was the equation for L1. And now what we need to do, we have the equation for L2, which is R is equals to 314 plus mu times 159. Okay, so we need to show that these lines do not meet each other. All right, so first of all, I'm going to write the equations in an expanded form. For L1, I can say that R is equals to the I component will be 6, J component will be 6 minus 6 lambda, and K component will be 2 plus 5 lambda. And for the line L2, I can say that R is equals to I component is 3 plus mu, J component is 1 plus 5 mu, and K component is basically 4 plus 9 mu. So if the lines meet each other, they would have a common point. That common point would be the point of intersection, and the position vector of that point of intersection would satisfy both the lines L1 and L2. But here we need to show that they do not meet. So first of all, we are going to equate the equations with each other. So first of all, I'm going to equate the I component with I component. So 6 is equals to 3 plus mu. So now we can First of all, find the value of mu. So mu is equals to 6 minus 3. The value of mu is 3. Now what I'm going to do, I'm going to equate the j component with the j component. So 6 minus 6 lambda is equals to 1 plus 5 mu. And the value of mu we have already found by equating the I components. So 6 minus 6 lambda is equals to 1 plus 5 times 3. So therefore we can say that 6 minus 1 minus 15 is equals to 6 lambda. So 6 minus 1 minus 15, this is minus 10, and therefore lambda will be equals to minus 10 over 6. The value of lambda is supposed to be minus 5 over 3. All right. So as you have seen that I have obtained the value of mu by equating the I components with each other, and I have obtained the value of lambda by equating the j components with each other. So now what I'm going to do, I'm going to substitute the value of mu and the value of lambda respectively into the k components so that I can see if left hand side is equal to right hand side or not. And since we want to show that the lines do not meet, they won't have any point in common. So this essentially means that the left hand side and right hand side of the k component would not be equal. Okay, as we want to show that the lines do not meet. So 2 plus 5 times lambda is equals to 4 plus 9 mu. And now I'm going to substitute lambda and mu respectively over here and show that left hand side is not equal to right hand side. So 2 plus 5 times minus 5 over 3. This is equals to 4 plus 9 times 3. And now I'm going to show that the left hand side and right hand side are not equal. So 2 minus 25 over 3. And here we have 4 plus 27. Okay. So 2 minus 25 over 3. This is minus 19 over 3. And 4 plus 27. This is 31. So left hand side is not equal to right hand side. So now I'm going to make a sign like this, and therefore I'm going to say left hand side is not equal to right hand side. So this essentially means that these two lines have no point in common. They don't have any point of intersection. Okay, so therefore we can conclude that the lines L1 and L2 do not meet since the values of mu and lambda do not satisfy the k component. Okay, if you use the values of mu and lambda, which we have obtained by equating the I components with each other and j components with each other, so if you substitute them back into I and j components respectively, so obviously you will get left hand side equals to right hand side. So all we need to make sure is that the lambda and mu, do they satisfy the k component or not? Okay, so the third component which you haven't used in order to find lambda and mu, you have to use that third component in order to see if the left hand side is not equal to right hand side. So if the left hand side and the right hand side was equal in the k component, then we would have said that lines, they do intersect. But in this case, since in the k component left hand side is not equal to right hand side, therefore the lines do not intersect. So this was the answer of part B, and like this you have to make a final conclusion. So now let's move on to part C. So here we have some information before part C, that point C is on the line L2 where mu is equals to -1. Find the acute angle between AC and L2. Give your answer in degrees correct to 1 decimal place. So here I'm going to erase the working of part B so that we can solve part C on the same page. So as we know that in order to find point C, we need to substitute u is equals to -1 into the vector equation of the line L2. So L2 equation is basically R is equals to 3 plus mu. The J component is 1 plus 5 mu and K component is 4 plus 9 mu. So in order to find the position vector of point C, we need to substitute u is equals to -1. So 3 plus -1, 1 plus 5 times -1, 4 plus 9 times -1. So therefore we can say that the position vector of point C is the I component is 2, the J component is -4, and K component is -5. So 2 minus 4 minus 5, this is basically the position vector of point C. So as you want to find the angle between AC and the line L2, so first of all, we are going to find AC vector according to vector subtraction law. AC is equals to OC minus OA. So OC is basically 2 minus 4 minus 5, and OA vector is given to us in the question, which is 6, 6, 2. So therefore we can say that AC vector is equals to -4 minus 10 minus 7. So as we want to find the angle between AC and line L2, so let's say this is line AC and this is line L2, and we need to find the angle between them. Okay, so for that purpose, we are going to use the formula of the scalar product by which we can find the angle. All right, so we can say that the scalar product of AC and the direction vector of line L2, the scalar product is equals to the magnitude of the vector AC multiplied by the magnitude of the direction vector of line L2 multiplied by cos theta. So AC vector is -4 minus 10 minus 7 dot the direction vector of L2, which is 1, 5, 9, and this is equals to the magnitude of the AC vector first. So under root of -4 squared plus -10 squared plus -7 squared multiplied by the magnitude of the direction vector of L2, which will be under root of 1 square plus 5 square plus 9 square multiplied by cos theta, where theta is the angle between AC and line L2. So I'm going to continue my working on the top. All right. So the scalar product would be -4 times 1, which is -4, plus -50 plus -7 times 9, which is supposed to be -63. Okay, and this will be equals to the magnitude of the vector AC is under root of 16 plus 100 plus 49, meaning under root of 165 multiplied by the magnitude of the direction vector of L2, which is under root of 1 plus 25 plus 81, which is supposed to be under root of 107 multiplied by cos theta. So therefore, -4 minus 50 minus 63, this is -117. So in the next step, I can say cos theta is equals to -117 divided by under root of 165 multiplied by under root of 107. So therefore, we can say that theta is equals to cos inverse -117 divided by under root of 165 times under root of 107. And as you can see that the value of the scalar product is less than 0. So theta, which I'm going to find right now by this formula cos inverse, so this angle would be obtuse. And then we would need to subtract it from 180 degrees in order to find the acute angle, since the requirement is to find the acute angle between L2 and AC. So cos inverse minus 117 divided by under root 165 times under root of 107. This is supposed to be 151.708. Okay, so this is basically an obtuse angle. All right, so we need to find the acute angle. So therefore, the acute angle would be 180 minus 151.708 degrees, which is supposed to be 28.292 degrees, and we need to give our final answer correct to one decimal place. Therefore, acute angle between AC and L2 is 28.3 degrees correct to one decimal place. This is supposed to be our final answer. All right. So this was the question number 8 of International A Level Edexcel P4 January 2022 paper.